So if you have any question, you may ask. Any clarity? I'm around. So how far are you? Anyone? Tutorial 2, question number what? How far are you? Is there anyone there? Can you hear me? Yes. Sirak. Tato.
Sir,
Okay. Yes.
so on question 12, tutorial 2,
Tutorial,
question 12.
tutorial 2, question number 12. Yes. What's wrong with that?
So there's the N, the capital letter N. Is this
Okay.
1/8? Is the population
Size.
the size of a population?
Oh, you need the population size or sample size?
That N,
Which
is it the
one? Big
population
N
size,
or
right?
small N? Eh?
Big N,
Yes,
the 1/8.
1,200. It's a 1,200.
1,200 is the small letter N.
Oh, which one? What about that 552 is what?
The 552 is the summation of Y.
Oh, yes, you're right. So that one is
Yes.
X over sample, which is 1.2.
So,
Okay. So you need the
yes.
population size, big N.
And the population size is the 1/8. 0,0,0,0,0.
180,000. Oh, yeah, it's down there. Yes. Thank you. So
Yeah.
what was your question anyway?
So my problem was the problem between the small letter N and the capital letter N. I was swapping the two somewhere somehow.
Oh, yeah.
I wanted to see if like the N is the small letter N, the 1,200.
Yes. It's a sample size, that one. So that one 18,000, it's a population size, capital letter N.
Okay.
Yes. So you can calculate your proportion.
So, and again, question 9. Letter B.
Question number. Yes.
That thing is without replacement, right? Then it means it's N, capital letter N. That it will be 16. I have 16 samples.
Yes.
Then again they said, but distinct units. So
Yes.
it means
You have
the
to.
10 and the 10 is out.
So you have to remove those that are not distinct. Okay.
And then say it's 10, 17 and 17, 10, the same thing.
10, 17, and 17, 10.
17, 10.
There is what we call distinct units, the one that they mentioned there, isn't it? And there is
Yes.
what we call distinct sample. Okay. So in this regard, I think we can just remove all of them. Distinct unit and a distinct. We have to include those that are not distinct in a unit, and those that are not distinct in the what, in the sample. So you have to discard them as well. So that means if you have 10, 17, and 17, it's like you have one thing, so you can get rid of one. So because they are going to give you the same answer there, you get that. So that means you can take 10, 17, then you get rid of that other one, the second one, 17, 10. Are we still together?
Yes, sir.
Okay. So at the end of the day, how many samples are you having? Just want to compare with mine.
I have 6.
You have 6. But if you have included that one, 10, 17, and 17, 10, those that are of that type, you are going to have how many? Because those are the distinct what? They're,
I
they're
will
not
have 12.
distinct 10.
12.
Yes, you're supposed to have 12. So, but maybe the question there, it was not clear because they only talk about what? Distinct unit. And distinct unit is different unit. You can't have 1 and 1, okay? You can't have 2 and 2, okay? So, but for different distinct samples, if you want to include distinct samples, so that means you can, if you want to include them, so it's like you said, it's 13, 17, 17, 13. So, but in this case, they didn't include all of them. They didn't say distinct unit and distinct sample. So those who are having how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. They might be right because the question there, it was not specific. And then those who are having 6, so that means they have distinct unit and distinct samples. So for now, what can we say? We have to include both of them, distinct units and distinct sample.
No.
Okay, just leave that. So that means we are going to consider the data that consists of how many samples?
12.
12. Yes. So therefore, when you answer those questions that follow down there, so you are supposed to have 12 samples. I think it's clear.
Sir,
Yeah.
are you talking about question 9?
Eh?
Are you talking about question 9?
I can't hear you.
Is it question
You are
9?
fading. I can't hear you. Are
Is
you
it
far
question
from the
9?
mic?
Is it question 9 from the tutorials?
Yes, yes. Page 12. Is it page 12?
So, sir, help me.
Yes, I think it's page 12.
I see 10 here. So, which one is the 12?
It's not
I
page
see
12.
10. Yes, I see 10 samples. I see 10 of them here. So the 12, which one and which one? Because as if I can count here, I see 10 and 17, 10 and 13, 10 and 20, 17 and 13, 13 and 20, 10 and 10, 17 and 17, 13 and 13, 20 and 20. Which there are 10, which others which I don't see here.
Do you have 17 and 20?
I think that statement says or with replace.
Yeah?
I said 10 and 17, 10 and 13, 10 and 20, 17 and 13, 17 and 20, then 13 and
Can
20.
anyone assist
That's
him,
6.
please?
Then I have 10, 10, 17, 17, 13, 15, 20, and 20, which is 10.
Yeah?
Sir,
Yes?
Mr. Smanga, what he's doing
Mm.
is
I'm still there. Huh? It's me.
sir.
Yes? Can you hear me?
Yes, I can hear you, sir.
Oh, okay. Can you repeat your explanation then?
I'm saying Mr. Smanga is focusing on that problem when we say there is no replacement,
Oh, this one is with replacement. He has to replace
but
those
that
two.
statement
Mm. It's Mr.
yeah,
Subula, the one who's talking. Sometimes he fade away. I can't even hear whatever you're saying. Network problem, I think so. Mr. Subula, can you try again?
can you
No, some of we can't hear you. I don't know. Maybe it's the network wherever you are. So now
Sir,
you're gone.
sir,
Yes. You must do it
again,
with replacement. That's true. Yeah.
with replacement, at the end of 16 instead of 12.
With the replacement, you have 16, isn't it?
Yes, so the 12,
Then
which one are you talking about?
later, it's with the replacement, but distinct units,
what
isn't it?
about this thing?
With the replacement, you're supposed to get 16, but distinct is then that you are going to subtract those that are the same. Like I said you can't have 1 and 1, for example. Or in this regard, you can't have 10 and 10, 17 and 17. So you have to remove those ones because they are not distinct. They are the same units.
So, say, are they 12?
Yes, there are 12 in total.
So if it's 10 and 20 and 20 and 10, we don't
So
even need.
it's fine, that one, because it's not a distinct unit. That one is a distinct sample. So here we're talking about distinct unit.
If it's a sample, then we remove one.
Yeah, we remove one and then we're left with one.
Okay, sir.
Where is Manga? Are you still there?
Yes, sir.
So now you got it. You're clarified. Mrs. Manga? Hey guys, can we consider question number 11? Can you see that one? Are we still together?
Yes, sir.
Question number 11, can you see that one?
Yes.
Okay, let's consider that one. I just want you to, there is club 1 and club 2 with sample sizes, sample mean, and then the median standard deviation, and then sample standard error of a sample mean, the last column there. Do you know how to find that one, standard error of a sample mean? Is there anyone who can do it for us? The last column there. It's tutorial 2. I'm talking about question 11. Okay. So the table is like this. You have club 1 and club 2. Okay. Then you have a sample size. You have the median. You have the standard deviation. Then you have the standard error of a sample mean. Okay. Samples 10. Oh, there's no mean. Supposed to have a mean. Let me say y bar 0.9788. So this one is a median. Zero comma 98, sorry. 9852. Okay. Median is 0.9785. 0.984. 0.55. 0.52. So this one, standard error of a sample mean, I think they made a mistake. It's supposed to be 0, or maybe it's a matter of rounding anyway. It's supposed to be 0.174. and this one is 0,167. Okay. So my question is, do you know how did they manage to get the last column?
Yes.
This one. Can you help us?
Actually, we have a standard deviation,
Mm.
and then the formulas for standard error of a sample mean is going to be the
One.
standard deviation divided by the root of random sample.
Yes, that's true. It's S1 squared. In this case, you use the variance, and you have to square that one, then divide by n. So that is the standard error of a sample mean. So you're going to have 0,55, isn't it? Squared, then divide by sample, which is 10. The answer is what?
0.173925.
Yes, that is why I'm saying there. Maybe it's the matter of just rounding. There is 0,176. So I think it's the matter of rounding. It's supposed to be 0,174, something like that. Okay, you can do the same for this one. 0,164. This one is 0,64. 164, this one. Okay, so now it's clear. Now, I want you to find the, can you be able to find the mean of a sample mean? You know what is the mean of a sample mean? Mean of a sample mean. Mean of a sample mean is the expected value of y bar. That is the mean of a sample mean. Can you get that? Anyone? There's no one. There are many formulas, but another one is this one, the very simple one. Summation of y bar over n. Okay. And that means here you're supposed to have a total. So what is the total of a sample mean? So you add the two values of club 1 and club 2. What is the answer? What is the total for those two means, club 1 and club 2?
1.964.
Yes, very good. 964. Okay, so now you're going to have 1,964. Then you divide by what? Because it's the mean of a simple mean. You divide by what? Is it 2 or 10? Anyone? You divide by 2 or 10? You have to divide by 2. That is the mean of a simple mean. You don't divide by 10 because there are 2 here. You find the mean of these 2 here. So there are 2 values there, so you have to divide by 2. So what is the answer? What is the answer for that?
0.982.
0.982. 2. That is the mean of a simple mean, okay? So now, I want you to find the sampling error. Is there anyone who can find a sampling error for us? Here, the last column, this one. I'm creating another column here. This is a sampling error. So what is the sampling error of club 1? Anyone? So the sampling error of club number 1 will be y bar minus the mean of a simple mean. Okay. What is the simple mean of club number 1? Is 0, 9788, isn't it? Okay. Then you subtract what? The mean of a simple mean, which is what? 0, 982. What is the answer? Obviously, it's going to be a negative, isn't it? That is why
It's
we're
a
Yeah.
negative.
negative what?
2/05.
0.032.
Come again. Come again. Did you get this? I'm having a calculator here. Also, there is somebody who calculated for us. I'm getting minus 3,2 times 10 to the power minus 3. This is what you got.
Yes.
Yes.
Okay. Now, let's find again the sampling error of club number 2. So again, you have to do the same. Y bar 2 minus mean of a simple mean. So the mean for club number 2 is what? 0,
9852.
52, isn't it? Then you subtract the mean of a simple mean, the same mean of a simple mean. What is the answer?
Positive 0.0032.
It's the same as 3, 2, isn't it? So that is the what? The simple error of club number 2. Now, these values, you have to put them here. Okay. You have to put them here. The first one is minus 3, 2 times 10 to the power minus 3. Okay. And this one is a positive 3, 2 times 10 to the power minus 3. Okay. So now, for the sampling error, when you add these two, they must give you what? 0. Because those are the errors. So that our error can be 0. So when you add them together, they must give you 0. This is something that I wanted to introduce to you, that you must know that. How to find the sampling error. You must know how to find the standard error of a sampling mean. Actually, you know how to find the sample variance or standard deviation. And I know you know how to find the mean, the sampling mean, the same as the median. Any question? So this is something that I wanted you to know, and it's very important. So now you can continue with question number 12. There is somebody who has already calculated that one. What about question number 13? Then question number 14. then we can stop there. The stratified, we are going to do it next week anyway. And it's not part of a test or quiz, isn't it?
Sir,
Yes.
can we do question number 12? I want to compare answers.
Okay. Question number 12. Oh, can I give you the answer anyway? Because I can't just do it. You'll be lazy.
Okay.
Let me
I
just
don't
give
know.
you the answer so that you can compare it with yours.
Okay.
Said what? Question number what?
12. 12.
It's about the proportions. Okay. In my case, we're estimating the proportion. Okay. And my answer is 0.46 for this. And then the estimated population proportion, I find it to be 0.000207033. Okay, and the bound, I find it to be 0.0288. This is what I got. Is this the same or is it different from what you got?
Yeah, they're the same.
Okay, so I hope you know how to calculate it. So just go to question number 13. So question number 13, I didn't calculate it, but I know the formulas where how to apply them. So question number 13, are you getting it right? Is it question 13? Yes, question number 13. Are you getting it? The bound is 0,095. Okay. Somebody says it's 0,095. Let me write it down. I didn't calculate that one. So it's question 13. So what about the estimated population proportion? Somebody says the bound is 0, said 0, what? Can I see it again? Zero comma 095. So what you got it? You got 0,095 for a bound. Remember, to get a bound, you're supposed to get the variance first. Estimated variance of what? Estimated population proportion. Okay. So what about number B? What is the sample size? The sample size required to estimate the true population proportion. So if you are done with the question 13, just go to the last one, question number 14. For question number 14, I do have answers here. Estimated population proportion is 0.18. I think it's what I call that one. I calculated it. I think I got it as well. Yeah. So this one I got it here. It's 0.18. Is it 183? Yes, 0.183. So this one I calculated it. Or bound somebody calculated it. I don't know whether it's true. So give me the answers for question number 14. Estimated population total. Estimated population total. Estimated population total, then you find the estimated variance of that estimate. Huh? What is happening here? What was the question? Estimate the number of vouchers or the total number of vouchers. Okay. Down. Okay. Then place a bound. Okay. So it's the variance of this. Then later you find a bound. It is equal to 2 times this. Anyone? And it's easy because you are told that n times p is the total number of incorrect vouchers. P is the population proportion of incorrect vouchers. So obvious estimated population total is equal to what? N times P. They gave us the they didn't give us the population proportion, so it's like this. So then the population size is what? It's 250. Then we multiply by estimated population proportion, which is what?
0.4.
Yeah, it's 20 over. Oh, you mean the final?
20 over 50.
That's why I get
20 over 50. So the final answer is what?
what
100.
I think it gives me
100. Thank you. That is the estimated population total. Then from there you find the what? Estimated variance of that estimator. What did you get? This one. The estimated variance of that estimator. You're still calculating it.
Yeah.
Okay. You will tell me when you're done.
Zero 0.0039.
What is that? Estimated variance.
Yes.
Which formula did you use? Tell me the formula.
It's capital letter N minus small letter n over capital letter N into PQ over N minus 1.
Yes. It's like this, ne? So the answer is what? Can it be 0, something? Remember, n is what? It's 250. Then open brackets 250 minus 50. Oh, P estimate is what? Oh, is this one 250 over something? 20 over 50. Okay. 1 minus 20 over 50. Okay. Then you divide by n minus 1, which is what? 49. Then the answer is what?
I got 0.00392.
So in my case, where did I get this number now? You said you get 0, comma?
I will
it's trying to
if
see
I'm wrong.
like here.
So it seems
Hey.
like I used the wrong formula.
Oh.
Yes, that's the
When is
reason
it
why
0,
it was 0.0039.
Yeah.
Just use this one. I want to compare with mine.
0.00392.
Are you sure? So it's 250 minus 50 is 200. 200 times C. Let me see. 250 times 50. Okay. Give me something. 125. 12500. Right, it can be like that. So then just try to calculate it. 250 minus 50 is 200.
It's 244.897.
Yes, it can't be 0, something. So that is why I was wondering. Let me just write it down, mine. Because that one was something else. 244 point.
Say,
So what I
which
call
one?
estimated variance.
Estimated variance.
This one.
But your formula is different. Pillar formula is estimated variance of an estimated population proportion.
The formula is what?
Estimated
So what?
variance of the estimated
It's not for the
population.
total.
Or it's for the total.
Hey. It's not supposed to be like this. Verify, guys. But I think this is the correct formula. Yeah, I think it's correct. It's correct because this one we're talking about the proportion, isn't it? So instead of writing the variance here, we substitute by what proportion, isn't it? It was supposed to be S squared. Isn't it? Supposed to be S squared, but now because we're talking about the proportion, that is why we're using PQ. Okay? And
Okay.
and because we are talking about the estimated variance of that estimator, so we're supposed to have n minus 1. If it was a var of estimated population total, it's supposed to divide by n, not n minus 1. I think you have to be careful about that. So this is the true formula, I think so. So because we're dealing with the proportion, we replace the variance, the simple variance, by the simple p there, which is equal to 250 over 50. Any question? I think this is the last question for tutorial number 2. So next time you're going to do tutorial 3. Unless if you have any question. We just took only 1 hour for this because I think it's something that you have done before, so you need only the clarity. And please make sure that you practice all the questions for tutorial number 2. Question 1 up to question number 14, you must know that. So for those who are still calculating, please go on. If you have any question, you might ask me maybe some other time.